Yeah. All right, so we're doing Saturday subnetting live stream. So let's see if I can find this right here. Saturday subnetting live. I actually saw somebody on Twitter this morning that was talking about subnetting and taking some subnetting tests and trying to prep for the CCNA for subnetting. I'm going to teach a subnetting CCNA probably here in 3 weeks or so. So this would be something that I would do in the subnetting section of a CCNA. Yeah. And so what I'm going to do is just start covering some subnetting topics. This is going to be every Saturday live for about a half hour. So what we'll do first is we'll talk about, since it's the first one, we'll introduce the concept of subnetting, right? And then I'm going to talk a little bit about why we do this and why we break up networks, right? And so can you hear me all right? I just want to make sure my audio is working pretty well too. So why do we do subnetting, right? So part of this, and this is a YouTube video that I posted as well, some content, but is segmentation, right? Network segmentation. Awesome. So we're segmenting the network, right? What that means is, let's say in a corporate environment, right? I have sales guys, right? I have engineers, right? And I have sysadmins. And so when I want to make sure that the sales team isn't accessing servers and things like that the engineers are accessing, right? I mean, I could do that on like a per user basis, but what's actually a little bit easier for me to do, right, is segment the network. And so then I can do it on a per IP. I can do it. I can segment the network based upon IP address. So let's just say, right, my sales guys are 192.168.1.0. I don't know why they get the first address in the space, right? If you're here with me, you're probably part of the engineering group or the sysadmins, right? And so I would say we should be the first address in the space, but whatever. 192.168.2.0, right? And 192.168.3.0. All right, and so this is my subnet mask, right? And this defines this network that I'm on, the 192.168.1 network, right? And so if I want to break these networks up, right, for any number of reasons, I talked about security and access, but also there's a bunch of other things that are going on behind the scenes. So things like services, DHCP, other broadcast and multicast services, ARP, that type of stuff. SSDP, these types of things. So these all use broadcast services, which means they're going to broadcast to everyone in the subnet, right? So everyone in that subnet is going to get any of these services that are trying to identify or dole out IP addresses, identify IP address to MAC address bindings, right? These types of things, service identification and those types of things. So all of these things are going to be seen by everyone in the network. It will both bog my network down and represent a security risk because people can observe that traffic and then potentially manipulate the traffic as well or understand my network a little bit better. So there's a couple of reasons that we're doing this subnetting. I know they talk about subnetting as being like a huge focus of the CCNA or of these networking certs, and it really is. And I feel like sometimes it's such a huge focus that people kind of forget why we're doing this thing, right? Why are we doing this? What we're doing is we're trying to right? Reduce the amount of traffic in these networks. If you think about how they evolved over time, we didn't do this originally, right? We had bridges that came into place to do the segmentation, but even before that, we were in like bus topologies and stuff like this. So we started really populating the network with a bunch of stuff. Okay, so this is why we're doing it, right? So what are these things, right? So these are these slash notations, or the other notation I could have used, right, is our traditional dot notation, right? 255.255.255.0. Sorry, get my head out of the way. Right? So I could use this or this. And what does this mean? So let's take a look at what it means. Let me get my Saturday subnetting back up here. Saturday subnetting. So what does this mean? Right? What it means is, thank you very much. I think this is a topic that can be covered on a lot of Saturdays, and this is how I choose to spend my Saturdays. I hope it's how you choose to spend yours as well, learning subnetting. I also have my Starbucks here this morning. The wife made me go and get Starbucks. All right. So we're covering subnetting topics, right? So the first thing we need to know is how these IP addresses are built. These 32-bit IP addresses for IPv4. Your traditional IPv4 is a 32-bit address, right? Which means it's 4 octets. This is important because this defines how the subnets get broken up, right? And so our 4 octets are 192, right? .168.1.0. This is 8 bits. This is 8 bits. And 8 and 8. Those are these octets, right? 8 bits of ones and zeros, identifying a base 10 number. And so if these bits are identifying a base 10 number, right, then each of these is representative of 8 bits here, right? And each of these ones and zeros has to be representative of a base 10 value. And so that is in fact the case, right? The first bit is a 128, 64, 32, 16, 8, 4, 2, and 1. Right? That's actually what they're representative. I think I'm going to go back and do some of the more baseline stuff in another Saturday subnetting. I'm just kind of setting the tone here so that we have at least some semblance of the baseline stuff. What I'd rather do is some fun subnetting examples, right? So let's take an example, 100.54.18.9, right? So this is one of your standard examples is I'll give you a host IP address and a subnet mask, usually a slash notation because it's a little bit tougher to visualize that way, and a slash notation, slash or hack. You'll hear it hack all the time. A lot of military guys will use the hack notation. Some of the guys from industry will use it that way too, but you hear it all the time in military. Hack notation, right? And so if I gave you a slash 26, if I said this is the host IP and the subnet mask is a slash 26, then the IP address is 100.54.18.9, and the subnet mask is actually 255.255.255.192. Yeah, .192. Okay. Anyway, what that means is the last two bits in this octet are used to identify the network. So this is actually what the bit looks like. The bit structure looks like for that. 1, 2, 3, 4, 5, 6, 7, 8 bits. And so what this subnet mask is saying, right, is that these last 2 bits are used for the network. So now, if I know that these first 3 octets are used for the network, right, we can go into some more advanced subnetting topics, right, at another time, another Saturday. But what that means, and by more advanced, I mean we'll do some subnetting in the larger octets, in the larger network spaces. But for now, right, if this is the network, this is the network, and this is the network that you're on, literally the network that you are participating in, what traffic is local to you, then these octets here have to stay the same. Right? So with this subnet mask, 255.255.255.192, then I know that this is part of the network, right? The only thing that I don't know is the last octet, right? Because these all have to stay the same for you to be local to me, right? The last octet though is the question, right? So I need to define this value in binary first, and then I can decide which bits need to stay on basically for you to be part of the network, and then that will tell me, right, which network I am on. So if I define 9 in binary, 1, 2, 3, 4, and then your 1 should be on, your 2 should be off, your 4 should be off, and your 8 should be on, right? So this is how you define 9 in binary. And I said these 2 bits have to stay the same, right? So the question then, I guess I should have asked the question at the very beginning of this example, is what network am I on, right? Right? If this is my host IP and this is the network, and this is the subnet mask of the network, the hack notation for the subnet mask, then what network am I on? Well, I'm on the 100.54.18, we agree, right? But there's also some definition in here because 2 of these bits are used to identify the network in my world, right? What the network that I am on, because that's what this slash notation is saying. Okay, so if those 2 bits have to stay the same all the time, right? Then that means that this 0 and this 0 always have to be 0, right? What we're actually saying with this 255.255.255 is that every bit in this octet has to stay the same, every bit in this octet has to stay the same, and every bit in this octet has to stay the same. So if every bit in these 3 octets have to stay the same, if all 8, 16, 24 bits, right, in those 3 octets have to stay the same, then that number has to stay the same. Right? I think we can agree with that. This has to be the same, this has to be the same, and this has to be the same because every bit in that space has to be the same. Okay, so the only thing that has to stay the same now to identify the network that I'm on are these 2 leftover bits, right? So this has to stay 0 all the time, and this has to stay 0 all the time. So what we find easy then is, or the best way to start with this is to go, how do I define the range of those addresses then that network is a part of, right? And so the range of those addresses is the bottom of that range, right? Or the lowest value in that range is 100. So this is base 10, right? Base 10 and base 10. And this is binary, just so we're clear, right? I did base 10 and base 10 and base 10 because we could just convert it very easily, right? This is binary, right? So I've got 100.54.18. And right now I have 0, 0, and the bottom of that range, right? The lowest value I can make in that range is actually all of these bits off, right? And what that means is this is a 0, 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 and this is a 0, which means that these bits stay the same, and all the rest of them are off too. That's the bottom of that range, right? And the bottom of the range is also has another name, right? It's the network ID. Again, I said I was going to start in the middle here. I will at some point on my subnetting stream start from the very beginning, but I thought the middle would be a good place to start for the first Saturday subnetting. This is known as the network ID. That's pretty easy. If we turn all these bits off, right, this all zeros means that none of the bits are on, so this is equal to 0, right? So the network ID is actually 100.54.18.0, right? And then we want to define the top of that range, right? So this is how we define the entire range of addresses, right? And the top of that range would be all of these bits on, right? So if the bottom is all the bits off, right, then the top is equal to all of the bits on, right? So 100.54.18.0.0, remember these bits have to stay the same, right? And then all the rest of the bits that can be manipulated, these would be our host bits, have to be on, right? 1, 2, 3, 4, 5, 6. And I can actually do the math for you here too, right? So this is a 1, this represents 2, 4, 8, 16, and 32, right? And if you think about this, the next bit here is representative of 64. So if I did this math, and I can do it for you, 32 plus 16 is 48. 48 and 8 is 56. 56 and 4 is 60. 60 and 2 is 62, and 61 is 63, right? So this is actually equal to 63. And I knew that for a few reasons, and we can talk about them with block sizes and things like that, right? But this is actually, right, the broadcast ID, the last bit in that range. These both have words, which is kind of why oh my goodness. Hold on, you ready? Let's go like this. For 1 second, while I show you these numbers. The broadcast ID, right, is equal to 100.54.18.63. Yeah, and so this is the range of addresses, right? And when they ask you for, let's say on like a CCNA or something like that, when you get asked for a number of usable addresses, right? You actually can't use the beginning address. You can't use the 0 because that's the network ID that identifies the network you're on. And you can't use the last address because that's the broadcast. So that's how I broadcast to everyone in that space, right? Because these are what are known as broadcast multi-access links that you're defining here. So in this case, if I can't use the first and I can't use the last, 0 to 63 actually defines 64 addresses, right? And so I can't use the first and last, so I have 64 total, and I can't use the first and last, which gives me 62 usable addresses in this space. Yeah. So this is a quick subnetting example. Yeah. I can actually, we can go back and talk a little bit more about these things too. So let's get rid of some of this stuff here. Subnetting Saturdays is what this is called from now on. Subnetting Saturdays. And I should be back. I'm back. There we go. So you notice that this /26 was actually, right, we said 0 to 63 was that address range. And we said that these bits were actually off for that network, right? Let me get a little coffee. And so what you'll notice is the block of addresses that this /26 defined, right? Because it turned these 2 bits to network. So this is a block of addresses that I could use. All the zeros and all the ones in that block, right? And then I can change these, but they define new networks. So the block of these addresses is actually 64 total addresses, right? And so we call this the block size. I remember hearing one day Todd Lamley talk about inventing block size. He was like, I was teaching block size before the term block size even existed, Travis. If you don't know, Todd Lamley's the well-known author of a very prolific CCNA study guide. Yeah, the best-selling CCNA study guide outside of Cisco Press. Yeah. So anyway, a lot of people like to use the first address in the space example, right? Because it gives you the 0 to 63 sort of thing. What is more confusing to people, right, is when these bits aren't zeros, right? When these bits aren't locked into this 0, 0 space. So the bottom is all zeros and the top is 0, 0 and all ones, right? So let's try and take an example where these bits aren't locked in as zeros. They're locked in as something else, right? So let's try that. So what I'm going to do is I'm going to pick a new subnetting example. Again, these are actually off the dome. This is a Saturday subnetting live stream. I had an idea of what we want to do, but we're just picking examples. If you have an example you want to do, if you've seen something and didn't know why it was that case, then throw it up in the chat and I'll do examples live. No problem with this at all. So let's take a different example, right? Let's take 92.18.104.101, right? / 26. Let's take that 26 example again, but we're going to talk about the bit confirmation a little bit differently, right? So this is host IP. Right? So this is an actual host on that network, 92.18.104.101. This is some PC's address, right? And the PC also has a subnet mask of /26, and we said again that the /26 is actually a subnet mask if you were to put it in like a Windows TCP/IP box, right? 255.255.255, or if you were to define it in, let's say, Cisco CLI too, their command line interface, right? .192. Okay, Remember we said that the first 3 octets here have to stay the same because they are all network bits. So I'm going to go into some of these more complex subnetting examples, but let's just say for now, right, based upon this subnet mask, that all 3 of these stay the same. 92.18.104. So all we're messing with is the last octet. The last octet. That should be a movie. It's like The Last Samurai or something like that, right? The last octet. Bum, 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 bum. No? All right. The last octet. The first thing that I need to do here, and again, I'm doing this very explicitly. There are quicker ways to do this, right? But the first thing that we need to do here, if we want to do kind of an explicit subnet definition from the host IP address, is define this base 10 number in decimal, right? In, sorry, not decimal, in binary. Base 10 would be decimal, right? Binary, right? And so the way that we do that is we define the 8 bits to make this number, right? So to make 101, I can't have the 128 bit on, right? Because if I added 128 to a number, it's always going to be bigger than 101. But I do need the 64 bit on, right? So if I turn the 64 bit on, right, that means I've got 64 that needs to be added to the number to make the number. If I turn the 32-bit on, 32 plus 64 is 96. So I can turn the 32-bit on as well and not still get to 101. If I turn the 16-bit on, that's too much, right? 96 plus 16 is 112. That's going to be too much, right? So this has to be off. Let's make sure that that looks like an off. So this has to be off. If I turn the 8-bit on, right? 96 plus 8 is 104. I can turn the 8-bit on and that's just fine. So 8's on. 104 plus the 4-bit is 108. That's fine. So now, oh, I thought I was going to 109. I'm going to 101, then that's not good. 104 is no good. 108 is no good. Yeah. So these actually have to be off, right? I'm going to 101. So if I add 8 to 96, that's 104. That's wrong. That's wrong, Travis. Yeah. If I add 16, 8, 4 to 96, that is actually fine, right? So 96 plus 4 is 100. Now I've got 2, and I need to turn 1 on to get to 101, right? So 64 plus 32 is 96, plus 4 is equal to 100. Plus 1 is equal to 101. Okay. So we've gotten to the value of 101. This is binary, right? Expressing the base 10 value of 101. Okay. And then what did I say? In a /26, to get to the value 192, I actually have to turn the first 2 bits on, right? And then the last 6 bits are off. And so these 2 bits have to always stay the same. If these bits always have to stay the same, these are the 2 bits that always have to stay the same, right? The 0 and the 1. So again, let me express the top and the bottom end of this range, right? So top and bottom. Sometimes we'll call this the first and the last, right? So, and you either say first and last usable or first and last in the range, right? Those are actually 2 different numbers, but we'll talk about it on another Saturday subnetting stream. So the top address, 92.18.104.01. So this is base 10, but I'm now back to binary. 0, 1. And then what did I say? To get to the bottom, I just turn all the bits off, right? 1, 2, 3, 4, 5, 6. And what is this in base 10? This is just the 64-bit on. This is 64. Ah, now we have a new network ID that's not a 0 network ID, right? That's not our traditional, right? These are when people get confused because your normal network is 192.168.1.0 or .2.0, right? With the /24s, they're always on a 0 boundary. With a /26, a /27, a /28, they're not always on the 0 boundary, and this one, in fact, is not on the 0 boundary, right? Yeah, so this is actually 92.18.104.01. .104.64 is the network ID. This is the actual network that you are on. It's expressed not on the zero boundary, right? So I actually flipped this, right? Why did I say top and then bottom? This is really annoying. I always do the bottom first, so I don't know what I'm doing here, right? So this is bottom. Right, I turned all the bits off, and I kept the two network bits, network. Why are these network bits? Because they're defined as network right here. And then the top is all of those host bits, right? All of these host, so we call these host bits, right? On. So 92.18.104.01 1, 2, 3, 4, 5, 6. In this case now, we'll do the math, but I could tell you this is going to equal 127 off the top of my head, or I could actually explain it to you, which I'm going to do instead. So 64, right? So this is 128, that's off. 64 is on, plus 32, plus 16, plus 8, plus 4, plus 2, plus 1. And we're gonna do the math here, right? To convince you that we know what we're talking about, right? 96, so that's 64 plus 32 is 96. Plus 16 is 112. Plus 8 is 120. Plus 4 plus 2 plus 1 is 4 plus 2 is 6, and 1 is 7. 127. So the top of this address range is equal to 92 plus 18, not plus, 92.18.104.127. There we go. Let's see if I can highlight these things. So this is the bottom. And this is the top. All right, 64 to 127. All right, if you actually did the math, this is another, what? 64 block of addresses. 64 address block. Right? 64 is basically the 0 number, and then 64 through 127 actually gives you, and although it looks like a block of 63 addresses, it is in fact a block of 64 addresses. Yeah. And again, I can't use the .64 address because that defines the network, and I can't use the .127 address because that defines the broadcast address, how we address everyone in the space. And so if I subtract 2 addresses off of that, I get 62 usable. Why is this important? Because if I'm defining these subnets, I'm actually defining them for users. And so if I want to have a specific number of users, if I'm looking for 64 users, I can't use a /26 because a /26 is only going to give me 62 usable addresses. All right, we've been messing with /26s for a second here. And to be honest, we're actually pretty close to our Saturday subnetting live stream deadline here of our half hour. Can you believe you can't? I can only get through two. I can only get through 2 actual subnet examples in a half hour. It's unbelievable. Yeah. So if you think about, let's just give some things to think about for my next subnetting example, right? But for my next subnetting time, right? But what we're going to do is continue to expand upon the slash notation, right? Slash or hack notation. So we'll talk about /25s. Those are larger blocks of addresses because we're only using 1 bit. 26, 27, 28, 29, and 30. And 30 and 31 we don't use. Someone might say in the chat someday, hey Travis, I've seen the 31s used and 32 for something specific, and I agree with you, right? But in terms of general subnetting and let's say your basic networking certs like a CCNA, right, or a Net Plus, or even maybe like a Sec Plus when you're doing some firewall rules and things like this. Usually you're just in this range here. Subnetting Saturday. Every Saturday from here until the end of time. Awesome. So that was our /26 example, starting right in the middle here, right? We will break this down a little bit more from the fundamentals perspectives, and we will also go up into the /18s and the /17s and things like that. Anyway, that's my first Subnetting Saturday. We will continue on this path on another Saturday. We'll also continue with security and networking content during the weeks. Let's do it. Have a good one.